Welcome back, Chemistry 30. This is the last booklet in the Unit 5 equilibrium unit, 18.3, using equilibrium constants. So what we'll look at here is determining the equilibrium concentrations of reactants and products, similar to what we did before, except possibly rearranging the equation to solve for a certain number of reactants or product. So what is the size of the equilibrium constant used in determining whether a reaction is practical in making products or not, or because the larger the KEQ value is, the more products that are formed. And of course, from before there, we know how to figure that out. Okay, so the next question here. So assume the equilibrium constant for a particular reaction at this temperature is 1.6. Calculate what H2 would be. So first of all, looking at all these, they're all gases. So first of all, coming up with the equilibrium equation, you can see I've done in green here. H2O multiplied by CO over H2 and CO2. And it says here, calculate what H2 would be. So H2 here is on the denominator. To isolate H2, we would first have to bring it up to the numerator by multiplying each side by H2. It's like a balance here. What you do to one side, you have to do to the other. So H2 would cancel off on the right, and it would end up on the left. To isolate H2 now, we would divide by KEQ, because here it's H2 multiplied by KEQ. So divide by KEQ, divide by KEQ, as you see here, cancels out on the left, and we would be left with that. Or you can take a look here and see that, oh, here it is right here. A simple way to do it is just simply switch the places there, which is really what we did. And then it's easy, just simply substitute the equilibrium concentration. So my H2O, 0.240, CO, 0.280, KEQ, 1.6, and lastly CO2 is 0.320. Be very careful with this question. 0.240 times 0.280 divided by each of these. Now if you just want to do it in one step, press divided by, start bracket, 1.6 times 0.320, end bracket, because otherwise your calculator will be thinking that you're multiplying by this on top. So be careful. Type in your calculator. Make sure you get 0.131 molar as a result. If you don't get that, call me over and I'll see where you may have went wrong on your calculator. Okay? Do another one here. I'll get you to do this one. So at this particular temperature, now it's interesting here, different temperatures would have different values here. If this had been an exothermic reaction, and if I increased temperature, we'd get a smaller KEQ because things would be shifted to the left, just like we talked about in the previous section. So different temperatures would have different KEQ values. So we have to state which temperature it's at. So first of all, come up with the KEQ equation, and then it says here, what is NO going to be? So see if you can at least get the KEQ expression first, and see if you can rearrange the equation to solve for NO. So maybe pause the video right now. Okay, if you had a chance to do that, the blue part here represents what the KEQ equation is. NO to the 2 all over N2 and O2. Now we want to get NO by itself. And the equation right now has it as NO squared all over N2 and O2. So it's divided by N2 and O2. To undo division, you multiply by N2 and O2. Multiply the right, multiply the left. This will cancel out on the right-hand side, and we would be left with that. N2 times O2 times KEQ would be NO squared. Now, thinking about how do you handle that now? Think about back to math when we talked about x squared equals 9. To figure that out, it would be the plus or minus square root of 9. Whatever the exponent is, that's the root that you take. If it had been cube root, or sorry, if it would be x cubed equals 8, you take the cube root of 8. So in this case, it's squared, so we take square root. And we're only concerned about the positive root in this case. Mathematically, it should be positive or negative, but we only look at the positive one, or the principal root. So here, n o would be the square root of all of that. So just simply substitute in my n2 value, my o2 value, and my keq value right there. And we should get that. Now you should have a square root button on your calculator. You likely even have a cube root button on your calculator, so you shouldn't be too worried about that. If for whatever reason you don't, using exponent rules, if we were figuring out, let's say, a cube root, it'd be y to the x, start bracket, 1 divided by 3, end bracket. Or to do square root exponentially, it's 1 divided by 2 as the exponent. So try that, make sure you get that as an answer. And I also have a practice sheet for this, because I know this is only one sheet of paper and we're done right now. So if you want another practice question, it's in the study guide 18.3. Grab that, try that example, see if you get it, and then you should be ready to do the quiz. Okay, we'll see you soon.